Okay, so the question was how to solve a trig equation like this. Okay, first of all, I look at sine equals cosine in the following way. And I say to myself, is there a way of getting a 0 on both sides? No. There is no value for x of x that make these two be 0 at the same time. Impossible. Cosine is 0 at pi over 2 and 3 pi over 2, and sine is 0 at 0 and pi. So it's safe to divide both sides by cosine, because I'm not dividing by 0. So then the left-hand side is tangent x, the right-hand side is 1, and then I go to the unit circle, where tangent is 1. And there are two options. An option in the first quadrant, and an option in the third quadrant. So I will have two different angles. Yes, I can combine the two and write only one solution. I'm less interested in that, but you can, of course. I'm less emphasizing condensing solutions. That's fine. So now I have to ask myself, which angle has tangent 1? And the answer is pi over 4. And I will say plus pi k, where k is an integer from 1 to, or 0, 1, 2, 3, and so on and so forth. And the other one, if this is pi over 4, this is another pi over 4, another pi over 4, another pi over 4, and another pi over 4. 5 pi over 4 plus pi k. But yes, you have to remember this kind of analysis in which you say, okay, well, I have two different trig functions in there. I can't solve the equation. I have to use some mechanism that changes that trig equation from having two trig functions into one trig function. And I cannot simply say, okay, I'm going to divide by cosine. I have to make sure that cosine cannot be 0. In other words, cosine equals 0 is not a potential solution. Cosine is 0 at pi over 2 and 3 pi over 2, right? So when this is 0 at any of those, this is 1. So it will not, it's safe to divide. In other words, left-hand side cannot equal the right-hand side when cosine is 0. So I'm not excluding a potential solution. So these are the two options. Yes, you can condense them and just write, pi over 4 plus pi k, and that's good enough, because it will give you all solutions. Good. Anything else? Other questions for me? And yes, in case I scared you, no, I did not start 2.1. I didn't even say anything 2.1. I didn't mean that. Okay? Anything else? Anything else?
I guess just for the heck of it.
Sure.
8b.
Yes. Again, don't make me look for.
Yeah, it's 2 cosine squared x minus cosine x minus 1 equals 0.
Perfect. Okay. So obviously, this is an equation that is quadratic in cosine. So it's quadratic in cosine and also trig equation, right? So obviously, I have to solve for cosine first before I solve for x. In other words, I have to factor this polynomial in cosine and then solve. So can anyone give us a factored form of cosine squared, 2 cosine squared minus cosine minus 1? If it isn't factorable, let's say it's not factorable, it is, but let's say it's not factorable, I will say let cosine x be t, and I will write 2t squared minus t minus 1 equals 0, and I will use the quadratic formula. So remember, I mean, I always say to all my students, if factoring takes more than 30 seconds, you should forget it. Just use the quadratic formula. 1 plus or minus the square root of 1 squared minus 4ac over 2a times 2. And take it from there. So I don't want you to waste time on factoring. If it's Fine. If it takes longer, just replace cosine by t, create a quadratic function and quadratic equation, and solve using the quadratic formula. So I have, this is the square root of 9, which is 3. So then t equals 1 plus or minus 3 over 4. So the options are, one option is 1, and the other option is -1/2. And you don't have to go back and factor. You're done with that. Does it make sense? Was it too fast? Do I have to remind you of the quadratic formula? Anyone?
Please, I'm just going to be honest.
Sure.
Can you run that back on me?
So the quadratic formula?
No, just like how you did all of that, because that was like real quick.
So I replaced cosine by t, and I said 2t squared minus t minus 1 is this equation, and I used the quadratic formula.
Okay.
So minus b plus or minus the square root of b squared minus 4ac. I can write it for you. So negative b plus or minus the square root of b squared minus 4ac divided by 2a. Because I didn't want to waste time with factoring. Basically I wanted to show you the other option. So you know that this is not the only option, and you don't have to sit there and spend 10 minutes on factoring. There is no need. If it takes 20, 30 seconds, do it. If it doesn't, if it takes you longer, forget it. Use the quadratic formula. That's why we have it. Is this okay now, everyone? Don't let me move on if you have questions. Is this okay then? Yes? Okay. And then we have two options for cosine. So the first option for cosine is 1. And the second option for cosine is? Very good. So when we solve the first one, remember cosine is 1 here, and it's -1 here. It's 0 here and 0 here. So 1, -1, 0, 0 for cosine. So then there is only one option, which is 0 plus 2 pi k. So the option from here for here is 0 plus 2 pi k, where k is 0, 1, 2, dot, dot, dot. And you don't have to put the 0 in front, of course. Now for cosine equals -1/2, that will give us two options. Any questions on the first part? Any questions on the first part? Any questions? Are we in agreement with this? Please say no if we're not. Yes? Okay, so the last part, which is cosine x equals -1/2, gives us two options. Let's look at the unit circle. Cosine is negative on this side and this side because cosine is measured on the x-axis. So cosine is negative in the second and the third. Now, anyone remembers cosine of which angle is 1/2? Not negative, just 1/2. Cosine of which angle is 1/2? And it's not the tiny one, because sine of that tiny one is 1/2. It's the other one. Pi over? Yes. So indeed, this, you have to make it pi over 3, not pi over 6. Sorry about that. I have to make it larger. I divide the quadrant in 3. 1, 2. So it's right here. So this is pi over 3. This is also pi over 3, the reference angle. So therefore, I have pi minus pi over 3, or pi plus pi over 3, because the angle is this, one option, and the other angle is this option. So pi minus pi over 3 will be, because I have to stop here. From pi, I have to subtract pi over 3 to get this angle. So pi minus pi over 3 is?
2 pi over 3.
Very good. So x equals 2 pi over 3 plus 2 pi k. And this one is pi plus pi over 3. Pi plus pi over 3 to get the other angle.
4 pi over 3.
4 pi over 3. Any questions? Any questions for me? Please ask anything. Okay, so do you have anything else? Is this okay? Everyone, is this okay? Okay, so now we can start 2.1. In 2.1, we will look at what we looked at last Monday, but a little bit different approach, and this time using some numbers. Okay. So I would like anyone to give me a function. Let's say a quadratic function. Okay, let's say negative 2x squared
Minus 5x plus 4.
Good. Okay, so this is a quadratic function, and I would like you to create a point. A very simple point. I can't. I cannot choose both variables. I can choose one and calculate the other. 0, 0 is not a point on this graph. But 0,
3.
not
4.
yet. 0, 4. Yes, I agree. 0, 4 is a point on this graph. Do we agree?
Yes.
Because when x is 0, y is?
4.
Yes. So this function that we just created has this point somewhere on it, 0, 4. Here's what I would like to do now. I would like to find the average velocity, assuming that this is a distance, the average velocity between P of 0, 4 and Q, and I'll give you x and you'll give me y. X, comma, no, just x. You're right. I'll do that too. X, comma, of course, there is no doubt. If it's x, it must be f of x. If it's 0, it must be 4. Good. So I would like to determine the average velocity. This is a piece of cake, right? So that will be the slope of PQ, which is the average velocity between P and Q. There is nothing there to be done. And you will dictate, and please replace the function directly. And what will you say? Yes, which is negative 2x squared minus 5x plus 4. And then you will say minus, very good, divided by?
X minus.
Perfect, for everyone to see. Do we agree with this? So the average velocity between these 2 points, P and Q, will definitely be that. F2 minus F1, or I should say, if you want, this is normally f of x2 minus f of x1 over x2 minus x1, or y2 minus y1 over x2 minus x1, correct? No doubts about that. Perfect. So I notice that 4 and negative 4 go away. So the average velocity becomes negative 2x squared minus 5x divided by x.
Can you take away the x?
I will.
So negative 2x minus 5.
Very good. So it turns out that the average velocity, it happens that the average velocity between P and Q is negative 2x minus 5. Now I would like to determine, that's my next question, find the instantaneous velocity at P. And this is a very simple situation. And we will look at another problem in a minute. What will I have to do to determine, based on what we discussed a minute ago with this? If you remember, we said this is the function that will give us the slope of the tangent line to the graph of the function that we use, the square root of 2x plus 1, at any point, of course, where the function exists, is defined, doesn't have a corner. These are the conditions that I would have to discuss with you later. So under certain conditions. So this will give us the instantaneous rate of change, the slope of the tangent line. So then what will be the answer now, you think? What will be the instantaneous velocity at P? Throw a number at me. What do you know about P? You cannot just pick a number. 0, comma 4. Good. So what would you put in that expression then? And the instantaneous velocity?
How do you have a velocity of the negative?
Very good. The negative direction. Negative direction. Yes. The negative direction or slowing down, depending on how you want to see it. So the instantaneous velocity at P is when x equals 0, because that's the x coordinate, and it will be instantaneous at P is -5. Okay, this was very simple, right? Here's what I would like to do now. I would like to look at a table. Let's create a table where x is 0, and I have very far away, I have 1, then I have 0.5. Where am I getting at? What am I trying to do? Closer and closer to? Right, very good. 0, 1, 0.001, 0.00001. And I want this to be the slope. And this, of course, will be the slope of the secant line. And here I'm going to conclude something about the slope of the tangent line. Disregard the answer that we got from the beginning, because of very simple algebraic manipulation by simply simplifying that. Okay, and the fact that we chose us as such a simple number, coordinates of P. Okay, so, and I can go even closer, whatever, 1. Okay, so between 1 and 0, so this is the point is 0, 4, and this point will be, let's say, my q 1, f of 1. I will determine a slope, correct? I will have MPQ as being f of 1 minus 4 over 1 minus 0. So I'm calling this one Q with coordinates 1. I'm going to call this one A and B and C, D, E, F. So can anyone give us the slope of AP or PA, maybe? F of 0.5 minus 4 divided by
0.5
minus 0. Thank you. Can anyone tell me, let's say I'm here already, the slope of PE? 4, I think there are 4 zeros, 1 minus, that's okay, 4 divided by this. right?
Yep.
And continue forever. Now, look at these three slopes. Is there anything in common here? A lot. There is 4 in common in all of them. There is 0 in common in all of them. And there is this function that is common. Yes, a different x, but it's the same function. So could I create, just because I want to show you how to do this with a calculator, I want to create another function which will look like this. So I copied the 4 everywhere. I copied the 0 that I don't even need. I copied the function, and this one is the x as well as here. This one is the x, which is 0.5 as well as here, and so on and so forth. True? And now stay with me. What was the function? A negative 2x squared minus 5x minus 4 divided by x. It was plus 4, right?
Yeah.
And then minus 4. Do not simplify, because that's a very unique case in which we can simplify. And let's go to the graphing calculator. And if you'd like, bear with me. And let's put this slope in. This function that we created. We created a function called slope, in which we created basically 3 situations. And using those 3, there are many more, right? But using those 3 situations, we figured out what is the pattern here. Because I don't want to plug these numbers in by hand. So left parenthesis for the top, negative 2 x squared minus 5x, everything divided by x. This is the slope, right? Negative 2x squared minus 5x divided by x. Now I want to go to the table. Make sure, go to table set. Make sure that the independent variable is in the ask mode. And then go to second and table. Are you with me? If you fell behind, let me know. And go to second and table. And now, what was the first x value from the first slope that we looked at? We looked at 2 points, one at 0, 4, and one at 1, comma, f of 1. Then we looked at another point, 0, 4, and 0.5, and f of 0.5. Then we looked at another point, 0, 4, 0.1, and f of 0.1. And then we looked at another one, and then another one, and then another one. So what was the first x value?
0.
Let's look. Right? So the first x value was 1, then 0.5, then 0.1, then 0.01, and so on and so forth. Correct? These are the numbers that I want to see. So when I plug in 1, I get a number. When I plug in 0.5, I'm closer now. You understand now Q is closer to P. Initially it was 1 unit away. Now it's at half a unit away. Now we're going to determine the slope with a point closer, and then a point closer, and then a point closer, and then closer and closer. So now I want 0.1. Now I want 0.01. Now I want 0.001. Now 1.0000000. I really want to be very close. Just give me the number. So we created secant lines. All of them were going through 0, 4. One with 1 comma, then 0.5 comma, then 0.1 comma, then and so on and so forth, and they eventually became what? They became the tangent to the graph at 0, 4, which is the instantaneous velocity at 0, 4. Any questions? Okay, so now let's choose a problem from your text, and this is the idea. I wanted to use a very simple situation. Yes, go ahead.
So the question,
Yes.
just so I make sure I connect here. So once we figure out the slope of the secant line, and we take,
They're all secant lines.
yes.
They're all secant lines.
So
I determined this PQ. They are 1 unit away.
right, that's a secant line, right?
Yes.
Okay.
And then the next one is a secant line.
And we
and
take
then the
the
next
slope
one is-
of that's the tangent line. Is that what you're saying?
As we get Q very, very, very close to P, that's why I started between 0 and 1. And then I said between 0 and 0.5. And then I said between 0 and 0.1. So the Q came closer and closer to P.
Right, but I'm saying we calculated the slope again the second time.
Right, without simplifying, just to show you how to create a function in the graphing calculator that will give you all the numbers without you having to determine this and get a number, this and get a number by hand, this and get a number by hand and put them in here.
Okay.
We created a function, which is this function. And I just put in the calculator and I boom, 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 I got all numbers. Otherwise, you would have to calculate this and put a number here, calculate this and put a number here, and then draw a conclusion. I didn't want to do that. I wanted to create a function so that I can get all of them in a blink. So I wanted to repeat the process because this is very important. So I would like us to choose, let me see where I'm with time, because I want to stop at an hour. Okay. So where are we? Good. So let's choose a problem, this time from your text. So you have an example of what I'm expecting from this section. And this is it for this section. So would you like problem 4? Here is problem 4. Let's see if you would accept problem 4. The point P 0.5 comma 0 lies on the curve y equals cosine pi x. If Q is the point x comma cosine pi x, what is this? Of course, x comma f of x. Use your calculator to find the slope of the secant line PQ, correct to 6 decimal places for the following values. And then using the results of part A, guess the value of the slope of the tangent line to the curve at this. Is this a good example? Yes? Is that okay with you?
Thanks for showing. Wait.
Yes. We need Paul's exception.
Yeah, sure.
Okay. So he agreed. Thank you. We're safe now. He's not going to chase us around. Okay, so problem 4 on 86. We are given y equals cosine pi x. And the point is P, 0.5 comma 0. And Q, of course, is x comma f of x. In other words, Q is x comma cosine pi x. Now, careful with these numbers. Careful with these numbers. Look at the numbers. 0, 0.4, 0.49, 0.499, 1, 0.6, 0.51, 0.501. Well, of course, they're throwing some numbers at us without any logic, if you want, without any order. But we have to notice that and say, wait a minute. Obviously, you will ask me to find the slope of the tangent line at 0.5. So 0.5, according to from 0 to 1, where is 0.5? In the middle. So I have to make sure that I create my table in such a way that I'm not messing this up. So my 0.5 is right here. And then I will put in those values. I see 0, fine. I see 1, fine. I see 0.4 and 0.49, so I see 0.4. I see 0.49, and I see 0.499. Then on the other side, I see 0.501. I see 0.51 and 0.6. Ready? 0, 0.4, 0.49, 0.499, 0.5, 0.501, 0.51, 0.6, and 1. Are they in the correct order?
Yes.
Very good. So please give me the function that will give us the slope of the secant line for all of them. So I can put in the graphing calculator.
Cosine
Very good.
pi x minus 0.
Right.
Or just cosine, and then x minus 0.5.
Very good. Awesome. y2, y2 minus y1 over x2 minus x1. Very good. Let's put it in, please. In the graphing calculator. That is the function that will give us in a blink all these numbers, so we don't have to do anything by hand. So in y equals, clear. Careful with parentheses because this is a rational expression, rational function. We have to have parentheses around the top and get cosine in this case because it's minus 0. You don't need it, but I'm going to still put it in. Cosine pi x, close the parenthesis, divided by x minus 0.5 in parentheses. Now, before I look at the table and I put in the values I want, what do I must check? What do I have to check? Sorry. What do I have to check? Yes, please.
Make sure that the table says attached.
No. Say it again. You may be right. I
The
didn't.
setting of your
Setting of the what?
the radical.
No.
Window?
Exactly. We do not use degrees in calculus. If the mode is not in radians, we're not going to be able to get anything. So go to your mode and make sure it's in radians. Because we have pi x in there. Very good. Thank you, Joey. So second and table. So I am going to put those numbers in. Which is the only number that I cannot put in?
0.5.
Of course, because the denominator will be 0. Perfect. So I start from left to right. 0. Enter. 0.4. Enter. 0.49. Enter. 0.499. Enter. If I make a mistake and put 0.5, what will happen again? Yes, of course, of course, of course. Okay, so 0.501. You will have to copy all these numbers in, right, when you present your work. 0.51, enter. 0.6, enter, and 1, enter. So I got all slopes of the secant lines, bless you, all slopes of the secant line approaching 0.5 from either side. From either side of 0.5. Now you can say, of course, these are what I'm looking at, right? When it's 0.49 or when it's 0.501. Or you will say, I don't trust any of those, so I want to plug in what? 0.5, 0, 0, 0, 0, 0, 0, 0, 1. I know for sure that that's the slope. Or I can plug in 0.4999999. And what should I get?
3.14.
Negative 3.142. I don't want you to do this by hand. You create a function, and you just plug in the numbers once you put the function in. Does it make sense? Yes?
So I'm looking at the graph. How come on either side of 0.5 there's a negative slope? Shouldn't the right side be positive? It's like moving upwards.
Say it again.
Looking at like just why is the slope negative on both sides instead of just on one side?
the both sides of this is the graph of the function.
Mhm.
So let's take a look. So at 0.501, so when you look at cosine to the left, so 0.5, this is pi divided by 2, right? So on the right hand side of so 0.5, this will be negative. This will be 0 actually, the 0.501. So on the 0.501 with the numbers greater than, this will be negative in the second quadrant, and this will be positive.
Okay.
So that's why the answer is negative. On this side, 0.49, this will be positive, but this will be negative.
Okay.
So in the first quadrant, cosine is positive with numbers less than pi over 2. With angles less than pi over 2, this is positive, but with angles greater than pi over 2, it's negative.
Mhm.
So on this side is positive, but the denominator is negative. On this side is negative, but the denominator is positive. Good. Any questions on this problem? Do we understand? You got an error for the 0.5? Yes, yes. For 0.5 will always give you a 0. So you cannot punch in 0.5. Any questions? Any questions? Okay, I'm still okay with time. Yes, please.
So the whole purpose of that was to find the slope, which we are just
To find the
guessing.
slope of the secant lines
Okay.
and then estimate,
Okay.
come up with the best approximation of the slope of the tangent line,
Which we estimate.
which is the instantaneous
That's
velocity.
3.142.
Yes, yes. Because the slopes of these secant lines, as the Q point gets closer and closer to P, they will come together to the same number. And that number will be the slope, the instantaneous velocity, or the slope of the tangent line at P. Okay, so here would be a graph. Okay, so of cosine. And by the way, to answer your question even better, this is the graph of the slope. This is not the graph of cosine. Okay. So let's say we're talking about cosine, and this is, let's say this is 0.5. Actually, I should graph correctly. So this is 0.5 for cosine. Okay? So we are looking at secant lines from here till here, and then from here till here, and then closer, and then closer, from this point to this point. And they're all negative, and they're all getting closer and closer to negative, what was it, negative 3.142 from either side. Does that make sense?
Yes.
Should I make a bigger graph to explain because this is tiny, too small? Is this better? No? Okay. So let's take a look. So this is the graph of cosine. So this is 0, and this is 1, and this is 0.5. So now I'm graphing the slope between these 2 points. I'm graphing the line between these 2 points. Now I'm graphing the line between these 2 points. So 0.4 is already very close. Now I'm graphing the line, the secant line between these 2 points. Now I'm graphing the line between these 2 points. Then I'm graphing the line between these two. And I determine the slope. Every time I graph a secant line, I determine its slope. And then I'm graphing these two. So it's already 0.4, so it's right here. And I determine the slope. And then when these points get closer and closer to P, I will eventually determine the slope of this line, which is negative 0.31, negative 3.142. Because I'm creating secant lines. And as they get closer and closer, this was one, then this is the other, this is the other, this is the other from this side. Then from this side, this is the next, this is the next, this is the next, and it becomes this. So that's how we determine all those numbers. So the first one is between 0 and 0.5. The two 0 comma cosine 0 and 0.5 comma cosine 0.5 pi. So that's how we got negative 2, and then so on and so forth. Is that better? Okay, good. Good, so now let's continue. Where am I? I'm on page 5. I think we're ready to move on to the limit of a function. So now let's discuss what a limit of a function is. So this is 2.2, limit of a function. So from our checklist, I highly recommend, as soon as you can, as soon as possible, complete part 1, complete part 2, you see if you have questions. I already created a function for you here. So determine part 2 and determine part 3. And this is, in number 3, you don't really have to do anything. I was just saying, just look at problem 7 on page 86. I should say here maybe redo problem 4 that we did in class. And check the answer that we got with what you get. Okay? So at least that. So now we are looking at 2.2. Let's look at a few situations, few graphs. Here's one. Here's another. Here's another. And in all these situations, I'm going to say we are looking when x is 2. Remember when we looked at, and I said the slope of the secant line approaches the slope of the tangent line, which means when h approaches 0 last time. We don't really like it to write it like this. We do have an operator. We do have a way, an elegant mathematical way of writing something like this. And here is how we read it, and here's how we write it. It's LIM as x approaches 2 from the function f of x, or limit of f of x as x approaches 2. This, by definition, means from either side. So this is the limit from either side. We have two more. Limit of f of x as x approaches 2 from the right, which means specifically with numbers that are greater than 2. From the right. And of course, we have LIM of f of x as x approaches 2 from the left, which means with numbers smaller than 2 from the left. Oops. Left. So let's come back to these three graphs, first of all, and identify what's happening there. Okay. So looking at this graph, if I ask you, what is the limit of this function, f of x? These all are f of x. F of x is here, f of x is here, and of course f of x is here. They're all our f of x in our discussion. So if I ask you what is the limit from either side of f of x, what will you say? You will say, on one side is this, and on the other side is this. What will the limit be? It does not exist. Both sides do not go to the same number. If both sides of the function, when x approaches 2 from either side, do not go to the same number, the limit does not exist. So I will say here, DNE. DNE. It does not exist. What will you say in this situation? So when x approaches 2 from either side, the function values the same thing. DNE, yes. Exactly the same thing. What about here? And I'm going to say that this is also 2. Or 3. I don't want to confuse you. That doesn't have to be the same number. Let's say 3. So what will you say in this case? The limit of the function f of x as x approaches 2 from either side is?
3.
Indeed. Indeed. Now, the function does not have to exist there. So this is a note. When we say find the limit may exist, although the function doesn't at that point. So here's an example. Remember what we said with h approaching 0? We guarantee h is not 0, right? So when we're asked here to find the limit from either side, we're not asked to plug in 2. Quite the contrary. We're saying as x approaches 2 from either side, the function values, we're not saying they're equal. We're saying the function values approach what number? 3. The function does not have to be defined at that point. It's fine if it is, but if it isn't, it's fine too. So in this case, the limit of function f of x, which is this, as x approaches 2 from either side, is 3.
Would it be the same on the other one too?
Which one?
The one.
This one?
Yeah.
Yes.
Okay.
Yes, it doesn't matter. The function can be defined or not. But here, the function is defined at 2. Is this number here, whatever that is. But the limit does not exist. Yes. Any questions on this? Any questions? Early in the semester, I would like to present a function, and I would like you to, we will graph it in a minute. We will prove the answer a little bit later, but we can also find the limit from the graph. So I want to find the limit of sine x divided by x as x approaches 0. When I plug in 0 in sine, what do I get? It's the other one. Cosine is 1, it is 0. Good. When I plug in 0 in the denominator, when I plug in 0 in here, what do I get? 0. I want to analyze this before we look at the graph. Note, 0 divided by 0 is not undefined. It's called indeterminate. Indeterminate case. There are seven such indeterminate cases. We will look at all of them this semester. So 5 divided by 0 is undefined. But 0 divided by 0 is not undefined. It's called indeterminate case. An indeterminate case means this is terminal. This one you cannot do anything, nothing. But an indeterminate case has hope. Has hope. Hope of the limit to exist. This, never, no hope. This is a terminal situation. 5 or any number other than 0 divided by 0, no one can change. This is it. But 0 over 0 has hope. So in this case, is 0 over 0. I'm not saying that the limit will exist. I'm saying it may exist. Here, there is no hope. Okay, so now let's graph this function, because we cannot really prove this today. We will. So let's graph this function. Go to sine x over x. So sine x, close the parenthesis, divided by x. And since we are looking at the limit as x approaches 0 from either side, I don't care to see the graph everywhere. I just care to see what happens around 0. So I'm going to change the viewing window, and I'm going to say, I don't know, -4 to 4, and with a scale of 1, and -4 to 4 with a scale of 1, and just graph. Do you think that the function exists at 0? Sine x divided by x, does it exist at 0? You can plug in 0 in the calculator, you'll see an error, right? Good. Can anyone tell us, as you see, there is a little hole in here? You see the empty? Okay, so can anyone tell us what is this limit? Exactly. This limit is 1. And this is one of the very important limits. And it's right here at the top. Sine x over x, when x, the limit of sine x over x is on your checklist. So this is number 5. Sine x over x, when x approaches 0 from either side, is 1. Also, the multiplicative inverse of that, x divided by sine x, is still 1. How do we need to remember this, however? And we do have to remember this. Please, like with tangent and arctangent graphs and, that we looked at last time, please commit this to memory. Okay? But this is not the way we should remember it. We should remember it like this. Limit of as long as all these 3 quantities are identical. If you put here 15x, you have to have 15x here, and you have to have 15x here. If you put x squared minus 5 here, you have to have x squared minus 5 here, and you have to have x squared minus 5 here. Only then this limit is 1. Okay? So all of them have to be the same. And I'm looking for a situation in which we analyze this. And on page, I don't see any. I'm going to have to make one up. So let's say limit as x approaches 4 from sine x minus 4 divided by 4x minus 4. What does this limit equal to? Thank you. Thank you. All this approaches 1, but there is a number 4 in there. So remember, x approaches 4 is the same with x minus 4 approaches 0. I moved 4 to the other side. So when I say x approaches 4, I mean the same thing by telling you, if I tell you that x minus 4 approaches 0. So now all conditions are fulfilled. This quantity, and this quantity are all the same. And of course, if I change this into 2, That's not going to be 1, right? So I have to have 0, and I have these 3 quantities that must be the same. And that is your 1/2. So you have an example here, and that's part of your homework, very similar to what we just did. Yes, please.
Okay, so limit as x approaches 4, does the little arrows function the same way like the equal sign would because you just moved the 4 side by side?
You mean this one?
Yes.
Yes. So when I say x minus 4 approaches 0, I mean x approaches 4. When I say x approaches 4, I say x minus 4 approaches 0.
But I mean, does it function the same way that equal sign would? Because I see like the second one down says x minus 4 as it approaches 0. So you can just
Yes.
add the 4 on
So
the side.
so I have sine of x minus 4, which is at the top. I have x minus 4 in the denominator, and I have x minus 4 here.
Got it.
So this is just an extra number that I put in.
Okay.
So if all this approaches 1, there is a multiply by 1/4. 1/4 times 1 is 1/4. Better? Okay. Very good. Now, I would like to look at a few examples and discuss just a, let me just stop this for 1 second. Yes.